Alright, math students, welcome to lesson 3.4c, multiplying and dividing rational numbers. This is Mr. Bruce in again for Mr. Peterson. Mr. Peterson is in apparently self-imposed exile, probably on some island living in a cave somewhere, like Luke Skywalker out of the last Star Wars movie, exiling himself so that he can work on all the math lessons so you guys can get ahead up to 8th grade. So he's probably doing okay, living off of washed up seagulls and ramen noodles without the flavor packets, but when he gets caught up, he'll be back. In the meantime, let's get to it. Okay, so multiplying and dividing rational numbers. We're going to use the same rules as for integers. If you guys have that hot pink handout that says integer rules on it, it has all the rules with examples to it. It works great. There's an example for every situation. I highly recommend you guys start looking at those. Okay, so the gist of it is, if the signs are different, the answer will be negative. If the signs are the same, the answers will be positive. Okay, that goes for multiplication or division. Alright, let's do some fraction examples. Okay, here we've got negative 2/3 divided by negative 1/5. Okay, so I'm going to set it up. 2/3 times 1/5. We're going to multiply across the top, and that gives us 2. Multiply across the bottom, 3 times 5. That gives us 15. Oh, I'm sorry, that was division. Back up. Alright, back up, sorry. This is a division problem. I read the sign wrong there. So for any division problem with fractions, we have to remember to flip the second fraction. Okay, it really doesn't matter which fraction gets flipped. Okay, when you see fractions and there's division going on, one of them things has got to get flipped. You just can't deal with it the way it is. Alright, so let's flip the second one just to be consistent. Alright, so negative 2/3 times negative 1, or negative 5/1. Okay, multiply across the top, and that gives us 10. Multiply across the bottom, and that gives us 3. Okay, now dealing with the negative signs, doesn't matter whether you put the negative signs on top, bottom, whatever, just pick a place, stick it in there. In this case, we've got a two negative signs together, so that answer is going to be positive. They cancel each other out. Okay, next problem. Negative 3 times 3/4. Okay, so we've got a whole number, negative 3. How do we turn that into a fraction? We just divide it by 1. Because negative 3 divided by 1 is negative 3. So now we just multiply across the top and multiply across the bottom. If we multiply across the top, 3 times 3 equals 9. 1 times 4 equals 4. Okay, and let's stick a negative sign in front of it. Now, it doesn't really matter where you stick the negative sign, okay? I could have stuck it on top with the 3. I could stick it up out front. I could stick it down bottom with the 1 and the 4. It doesn't matter. Negative 9/4 is the same as 9/-4. It all works out the exact same, whether you put it in front, on top, or the bottom. It's all the same thing. Okay, moving on. Now we've got 3 numbers to multiply together. Okay, we've got a whole number here, so we've got a whole number. We can change that into a fraction by just putting a fraction bar and a 1 under it. So it's 5 divided by 1. Okay, now there's different ways you could go about this. You could go off left to right, since it's all multiplication, and deal with the first 2. So let's do that first. Okay, so I've got 4/5 times 4/5 times 2/3. Okay, multiply across the top, multiply across the bottom. That gives us 8/15. Okay, and I've got 2 negative signs, so they're going to cancel each other out, and that becomes positive, right? I'm going to drop down my 5/1. Let me erase that real quick, make that nicer. Drop down the 5/1. We're still all positive. I can multiply across top. 8 times 5 equals 40. Multiply across the bottom. 15 times 1 equals 15. Okay, now that fraction looks pretty big. Looks like it can be reduced. And yes, it can. If you've got something that ends in a 0 or a 5, on either side of the fraction, then you can divide by 5. Okay, so I'm going to try that. Divide 40 by 5. That gives me 8. Divide 15 by 5. That gives me 3. So my final fraction is 8 over 3. Okay. Now if you've got all multiplication like this, you can also just multiply all three numbers across the top and multiply all three numbers across the bottom. That works too. Another little hint about dealing with these signs. I'm seeing a lot of errors when it comes to dealing with negative signs. Maybe this analogy helps. I think of negative signs as like that super annoying kid you knew in first grade who always wanted to play opposite day. You didn't like him. You didn't want to play with him, but he was so annoying and so persistent that you just kind of went along with it. So you said, okay, fine, it's opposite day. We'll play opposite day until he goes away. All right? So anytime opposite day kind of guy comes up, you go the other way, you go negative, and you stay negative. But if two of those opposite day kids show up, they're both really selfish and they can't play together. So they cancel each other out. They want to be the center of attention and they basically fight to the death and they cancel each other out. And you go back to normal, you go back to being positive. Okay, so if I see two negative signs multiplied together, or even two negative signs when it comes to subtraction right next to each other, they cancel each other out. Okay, so I'm just going to go ahead and do that right now. So that leaves me with all positives. Another thing about this problem that's kind of neat is since we are in the multiplication phase, there's no division going on here, I can start simplifying early. And I see a great place to do that. I've got two 5s. There's a 5 on top and a 5 on bottom. If I divide both of them by 5, then 5 divided by 5 is 1. 5 divided by 5 is 1. So now I've got a much simpler fraction to deal with. I've got 4 times 2 equals 8. And 1 times 3 times 1 equals 3. Gives me the same fraction. I would much rather simplify up front if I can. It just makes life easier, makes your multiplication more likely to be correct, and you don't have to think hard afterwards about how to reduce something. Okay, moving on. Decimal examples. Okay, multiplying with decimals, just like multiplying with anything else, we're going to deal with the decimals at the end in the case of multiplication. We're just going to work the number first, and then we're going to figure out where a decimal goes. Okay, so let's stack these numbers on top of each other. 2.7 times 3. I don't really care about the negative sign yet. I'm going to deal with the negative later. Okay, 3 times 7 is 21. Carry the 2 up there. 3 times 2 is 6. Plus 2 is 8. Okay, now I'm going to deal with my decimals. Okay, so I have one decimal just on one number, and it's one space over from the right. Okay, that's one space right there. So I'm going to do the same thing down here with my answer of 81. I'm going to come in one space to the right, and now my answer is 8.1. But wait, we also have two different signs. We've got a negative sign and a positive sign. So opposite day kid wins out, and it's going to be a negative. Negative 8.1. That's our final answer. Alright, next problem. Negative 9.6 divided by negative 1.2. Okay, again, I've got two annoying opposite day kids trying to play together, and they can't, and they're going to fight to the death and cancel each other out. So I'm going to just change those into positives just to get rid of them right up front. Okay, now we're going to set up our division problem, just like long division. 1.2, 9.6. Okay, and again, when you're doing this, try to be really clean and neat and orderly so that your numbers line up on top of each other really well and you don't lose track of your decimal spaces and where exactly your answers go. Okay, so I've got 1.2 and 9.6. Now I'm going to move my decimal places to the right. Okay, I'm going to take this 1.2, I'm going to move it to the right as far as it'll go, which is one space. If I do it to this number over here, then I also got to do it to my 9.6. I'm going to move it over one space because it's one space over here. So basically all I did is I multiplied both numbers by 10. I went from 1.2 to 12, went from 9.6 to 96. When I do the same thing to both numbers and I divide them that means I'm going to get the same answer. Alright, now I'm going to bring my decimal place up and go ahead and divide. Now it just so works out that 12 goes into 96 exactly 8 times. Right? 8 times 12 is 96. Subtract, I get a 0. Just for the heck of it, I'll bring another 0 down. So it leaves me with 8.0 as my final answer. Okay? And again, it's positive because those two negatives cancel each other out. Alright, 16 divided by negative 0.4. Okay, we're going to set it up as long division again. So 0.4 into 16. Okay, so with that decimal, again, we got to move it to the right until we run out of room. So that 0.4 becomes a 4. And here, I don't have any decimals. I'm at 16. My decimal would go here, but now I need to move it to the right, which means I got to add another 0. Because what did we do to both numbers just now? We multiplied them by 10. So now I have 4 times 160. Now I'm going to move my decimal up top over the 160. Alright, so let's start dividing. 4 doesn't go into 0, or 4 doesn't go into 1. I'm going to put a 0 here just so I don't lose my place. I see a lot of people start putting answers right up top all the way to the left, and that's a good way to make an error. 4 does go into 16 4 times. 4 times 4 is 16. Subtract. 16 minus 16 is 0. Let's bring our next 0 down. 4 does not go into 0, so we're going to put a 0 up top. And we can keep going. Bring another 0 down. If we had another number past the decimal, we could keep going, but our answer is 40. You can put 40.0s too, that's fine. 40.0s, that's also fine. And it's going to be negative. Okay, notice here, it doesn't really matter the negative sign here, whether it's on top, bottom, out in front. If you got one negative sign, it's all the same. It's going to give you a result that is negative. So negative 40.0, negative 40. Alright, next problems. Here we've got some try this problems. So feel free to work ahead, and when you're ready to check your answers, come back. Now, this first problem looks like a really tricky, screwed up fraction. But when you have a fraction bar, all that means is it's division, right? So really, this is 9 divided by negative 4/5. Okay? So let's write that out in a way that's more familiar to you, just for the heck of it. It's the same thing as saying this. 9 divided by negative 4/5. Okay? Maybe that's a little easier to visualize, but get used to this kind of notation here. This is actually pretty common. You'll use that a lot later. Okay? So now, how are we going to work with 9 divided by negative 4/5? Well, we got a whole number, so the first thing we're going to do is turn that into a fraction. How do we do that? We divide by 1. Okay, so it's 9 over 1. Alright, next thing, we need to flip this thing. So we're going to take our second fraction, we're going to flip it upside down. So now we've got 9 over 1 times 5 over negative 4. Okay? And again, you could put this negative wherever you like. It doesn't really matter. It started out front. I put it on top. Now it's on the bottom. It could be, negative 5 over positive 4. Doesn't matter at all. Alright. I don't see any place you can reduce it. We're in the multiplication stage, so we can start reducing if we see the opportunity. But I don't see anything here. So we're just going to go on and multiply across the top, multiply across the bottom. Okay, 9 times 5 is 45. 1 times negative 4 is negative 4. Okay? And you can leave your answer like this as an improper fraction for now if you want, or, divide it out. That's fine. I'll divide it out just because 4 goes into 4 one time, 4, drop down to 5, 0, drop down to 5, goes in 1, bring down to 4, 1. Oh, actually, let's just leave that remainder 1. We're going to leave it like that. So our other answer is 11 and 1/4. Okay, that remainder of 1 means it's a fraction of 1/4. Okay, so we could do either of these. Either of these is fine. And it's going to be negative, right? Okay, moving on. Question number 2. Problem number 2. Another division problem. What do? We got to flip that second fraction upside down so we can turn it into multiplication. So we've got negative 2/3 times 2 over 1, also negative. Okay? Beautiful thing here, I've got two of those opposite kid days trying to play together. They can't. They fight to the death. These turns into positives. Okay? I don't see anything to reduce here, so I'm just going to go ahead and multiply across the top. 2 times 2 equals 4. 3 times 1 equals 3. So my answer is 4 over 3, and it's positive. If I write that out as a whole number in a fraction, that's going to be 1 1/3. Either way. I actually like dealing with improper fractions better for stuff like this because it makes your multiplication and division a lot simpler. Decimal form, obviously that's different, but for fractions, dealing with this stuff right here is quite a bit easier. Alright, last problem. Alright, last problem. Fairly straightforward division problem, but dealing with decimals and a negative number. Okay, so let's set it up as a long division problem. Okay, we're going to divide by 1.3, so let me get my pen on here. So, write out as neatly as I can 1.3 and 32.5. Alright, so let's deal with our decimals. We're going to multiply both numbers by 10, which has the effect of sliding our decimals to the right one space. Did it over here to the 13. Let's do it to 32.5. My decimal slides over here. I'm going to put it up top. Alright. 13 obviously doesn't go into 3. It goes into 32. How many times go? It goes 2 times. Okay, 2 times 13 is 26. Subtract. Got to borrow here. Remainder of 6. Okay, now I'm going to drop down my 5. 13 just happens to go into 65 exactly evenly. It goes in 5 times. Okay, so 13 times 5 is 65. Subtract to get 0. And there's our answer. We could keep going here. Just so you know, it's 25.0. Okay, so it's 25.0, but I've got two different signs. I've got a positive and a negative, so that's going to leave me with a answer that is negative. Opposite day kid wins, because there's only one of them. There's our answer. Okay, hope that was helpful for you. If you got any questions, come grab me or Mr. Peterson in class. See you soon. Thanks.